Good morning. Welcome to the second session of Principles of Communication. To start with, we are going to see the recap of the previous class. In the previous class, we have seen the basic elements of communication system that we require to transmit information from one place to another. Either it might be at the next building, the next country, or from one end of the world to the other end of the world. So what are the basic equipments we need to transmit information? So to start with, the first block is your information source. To transmit information, I should have something to give it to you. So this may take the form text, audio, video, or image. Okay. So having an information source, this is passed on to the input transducer. So this input transducer is the equipment that gives the information in terms of electrical signals. So these electrical signals are fed into the transmitter, who is responsible to transmit this signal over long distances via a communication medium, which we call a channel. This channel may be air, microwave communication, radio broadcasting, any type of medium we call it the channel. So any channel you take it is associated with a noise factor, and from the channel comes the other end where the electrical signals are received by the receiver, and this receiver gives these electric signals to the output transducer, whose task is to convert the signal into its original form. What was the original form? It may either take text, image, audio, or video. So this output transducer is responsible to give us the original information in its original form. So these are the basic elements of communication we have seen in the previous classes. Okay. So to start with today's class, I'm going to show you a set of pictures. Okay. Together we will interpret what every picture means with whatever we have seen in the previous classes. Okay. So we are just going to interpret every picture that is shown in the slide. Come on, the first picture. It is very obvious. Two girls are talking to each other. They are conversing with each other. Maybe she's showing something. She's showing some messages or whatever it is. Our area of interest is how they are conversing. How they are conversing? They are standing nearby, one to one. So to compare this picture with the basic elements of the communication system, whoever is talking will form the information source. Okay. So talking means it is our voice signal. So this voice signal travels through the air and it reaches the other girl's ear. So the other girl's ear becomes the receiver here. So since we are human beings, we are all inbuilt. Therefore, there are no transducers to convert one form of energy to the other. Everything is done by our system itself. So the main thing we have to see here is one girl forms the source, the other forms the destination, and air forms our channel, from which the voice note travels from one person's mouth to the other girl's ear. Done. The second picture. Yes, in this second picture, it is very, very evident that one person is trying to communicate a message even more louder to a lot of people using a speaker. So how do we interpret the basic elements of a communication here? The person who is holding the speaker is the source. That means he is going to give his voice note. The speaker is your transmitter. That is, it probably receives the note from the person's mouth and it amplifies. That means it makes his sound bigger to be heard by a lot of audience. In the previous image, it was a proper one-to-one communication, and here it is a broadcast communication. Okay. Third one, yes, the picture shows two persons standing nearby, but actually we interpret it as being apart. You can see a cloud over there in the picture. That means these two people are communicating, but the medium is different. So here comes the basic elements of a communication. The one who is talking forms our source. He is holding some equipment with him, that is towards his mouth. That is our transmitter. The wire is the transmission channel here, and the other person is holding something which is called a receiver, and that receiver is responsible to translate whatever it is received from the wire to something that can be interpreted by the human ear. Okay, so this is the third form of communication that is happening. And the last one. So the last one you can see is what is being used in the digital era. So in today's digital era, what happens here is, it's pictorically represented here, satellite communication. Okay, now whoever you take, everything, every communication takes place via your satellite. So you have a satellite here. Say for example, if I want to communicate, my information is transmitted through an antenna who will receive these signals. So wherever, whatever intermediate device you want. So that is the example for a thunder there. So whatever hindrances it takes place, doesn't mind, it goes to the satellite, and via the satellite, the other person will receive the information. So this is happening in a digital era. This is how the information or communication transfer has occurred from one form to the whatever we are using it today. Hope it is clear. Okay? Yes. So now what are we going to do, or what are we going to see for today's class? So whatever we are going to see for today's class is clearly going to talk about the basic functional differences between the three elements of a signal, which are amplitude, frequency and phase. That is amplitude modulation, frequency modulation and phase modulation. And we are not going to stop with this. We are also going to look into some encoding techniques with which the signal can be encoded and transmitted. Why we are doing encoding and decoding is, when you are adding redundancy to the signal, it becomes easier for us to transmit it and compress it, most importantly. So the size becomes very minimum, and the bandwidth required to transmit the signal becomes very small. So this is the content of today's class. Okay, so today's session is going to be split into three different parts. The first thing is, we will learn to interpret the basics of signal modulation. So by merely looking at a picture or a signal, we should be able to identify whether it is amplitude modulated, frequency modulated or phase modulated. Done? The second one, I told you about coding techniques. So everything has an evolution. So we start with the basic evolution, which is unipolar, migrate to polar, bipolar and Manchester line coding techniques. We are going to see how the signals are interpreted in each of these line codes. And yes, probably given any signal, we will learn to analog to analog conversion, analog to digital and digital to analog conversion. We will be able to perform. Done? So these are the three parts or three sections of today's lecture. So the first one, right away we will start with modulation. Yes, I'm going to tell you a simple narration here. So imagine we are all sitting in a classroom. Okay, so take for example, the person in my right end would want to communicate to a person in the left end of the classroom when I am taking the class. So you cannot directly shout, right? So there are two methods you can do it. One is, you can write a chit and you can pass it to your intermediates. Done? And the second one is, you can write a chit and you can directly aim at the person whom you want to send the message to. I hope you can imagine. Now, I'll take this second method. In the second method, what happens is, I'm writing a chit. Okay? So, just like that, if I throw the chit, how far it will go? Probably to the next desk, or even if you go farther, if your wind is blowing in the direction of your chit, maybe to the next bench. But it will definitely not travel to the other end of the classroom or to the person whom you would like to send the message to. So now what will you do is, you will crush the chit into a ball, right? So the same paper, you have written the message in the paper and you are crushing it. Why are you crushing it? So if you crush and you make it into a small ball and you aim and throw the ball, crushed ball, definitely it will reach the person whom you wish to send the message to. Okay. So this process, why are you crushing? To give strength to the paper to travel from one end of the class to the other end. So this process, giving strength to the signal so that it can travel long distances, is called modulation. I have explained it in layman terms. What is modulation? Giving strength to the signal to make it travel to long distances is called modulation. Done. So this is the example how you are being communicating right now. So you can see in the red color box, they are the elements of communication systems. So you have your communication system with the input transducer, transmitter, channel, receiver, and output transducer. So the first thing shows your digital transmission. I told you it's your satellite. So any TV you take, Vijay TV, Sun TV, Jaya TV, BBC, NDTV, whatever it is, they use satellite communication. You have a broadcast station here. You have a certain set of frequencies. From that set of frequencies, the satellite will again broadcast it to the receiver. Okay, that is digital. What happens in the case of analog signal? Everything travels in form of electrical signals via wires or whatever it is, and finally it gets received at the receiver's end. Okay, so this is about the general communication system. So as I told you, this is the process of modulation, putting information onto a high frequency carrier. So this is the technological term we are supposed to use to define modulation. What it is? High frequency carrier. Embedding your input signal with a high frequency carrier signal for transmission is called modulation. Okay. So we have defined modulation. Excellent. Now, what exactly happens in the process of modulating a signal? So you can see in the left end, you have the information signal in its raw form. Okay. So this information signal is given to a device called as modulator. Now this device modulator is the sole responsibility to give the frequency or to give the carrier signal to the input signal, and the output of the modulator is your modulated signal. So as mentioned in the earlier slides, modulated signal can take the form amplitude, frequency or phase. Done. And so once this information is received at the other end, in the receiver's end, this low frequency information is removed from the high frequency carrier modulation and the original signal is retrieved. This process is called demodulation. So here it is that the function of the demodulator. So you have the channel output here. This output is given to a demodulator. Now this demodulator will remove the high frequency carrier signal and it will give us the original message. Okay. So yes, in a gist we have covered what is modulation, and we all know the definition, proper definition of the modulation, that is embedding a high frequency carrier signal to the input signal to make it travel over long distances is called modulation. Done? Yes. Here are two technical reasons why I need modulation. Okay. So first one, you can see this diagram here. So what can you observe from this diagram? You see a car or a jeep on the street. You see some truck or something. You see some 3G signals. You see some other forms of communication. Everything embedded into somewhere. Water is coming out. Everything embedded. You cannot provide the same medium for all these to travel together. Can you? It is highly impractical. You cannot combine all the forms of signal into a single medium. That is why we need modulation. Okay. So probably a human ear. Can you guess what is the frequency a human ear can hear? Hopefully this is a general knowledge question which everybody will answer. It is in the range of 20 to 20,000 Hertz, right? So we have to segregate these signals and we have to transmit only those signals that can be heard by a human ear. So apart from this, if you are going to transmit any other signals in the either ranges, it is very difficult. It is unnecessary also to transmit all those signals. So you have to separate. So the first reason why we need modulation is to separate the signals from each other, we need modulation. Okay. The second one. So just imagine if we are going to probably transmit a signal without interruption. You can see in this picture, you have to build antennas taller in such a way that it should probably hit the sky. Okay, so it is highly impossible to avoid distortion at nominal levels. Okay, so in order to make the process easier of building an antenna, we have to modulate the signal so that the size of the antenna will get considerably reduced and the signal will travel without any distortion, and the receiver will receive the signal as it was in the original form. Okay, so this is the second important reason why we need modulation. Two technical reasons. The first reason is we have to separate the signals. You cannot combine all the signals. How can you combine Vijay TV, Sun TV, NDTV? Can you combine all the three and transmit it in the same frequency? No, you will not be able to hear, or you will not even be able to visualize any one channel properly. Okay, so we have to separate the frequencies. So that is the first primary reason. And the second primary reason is, obviously, it is very impractical to build an antenna such long in such a way that any distortion cannot occur. It is impossible. So we need to give strength to our signal, so in order to minimize the size of the antenna. These are the two technical reasons why we need modulation. Done? The second topic for today's class is types of analog to analog modulation is what we are going to see. So the types of analog to analog modulation are amplitude modulation, frequency modulation and phase modulation. The properties of your signal. One, you are going to make change in your amplitude, or you will make changes in your frequency, or you will make changes in the phase. Done. This is wherever you are making the change, that type of modulation is this. Okay, very simple. So as IT students, it is sufficient enough for us to understand the concept. We are not going to derive any of the equations with respect to any of the modulation techniques. But the concept of understanding each of these is very important for us to build up communication medium. Okay. So the first one, you can see the first one is our modulating signal. The second one is your carrier frequency. Now you are going to embed this carrier frequency into the modulating signal such a way that you can see here the amplitude. You can see in the modulated signal, the amplitude has increased. Okay, the frequency remains the same, but the amplitude of the signal has increased. Okay, so what you need to do this is, you need a multiplier to give the input to give the amplitude modulation to your signal. So this is facilitated by means of the oscillator. Oscillator will give you your high frequency carrier signal. This multiplier will multiply both of these signals and it gives the amplitude modulated wave. Okay. So how much is the bandwidth required for an amplitude modulated wave? See here, you have your carrier frequency here. So left half is the single bandwidth and the right half is the second bandwidth. So you need 2 times the bandwidth required to send the modulated signal over the channel. So yes, the total bandwidth required for an amplitude modulated wave can be determined from the bandwidth of the audio signal. So bandwidth required for amplitude modulation is twice the bandwidth of the modulated signal. Yes, the next one is frequency modulation. So here we are going to make changes in the frequency and we are not going to affect either amplitude or phase. Okay, so you can see the first red color signal is your modulating signal, which is the original signal. The second is your carrier frequency, which is your high frequency signal, which you are going to embed into your modulating signal. And you can see the output here. You have the high frequency modulated signal as the output with respect to the time. So you can see the blue signal has the occurrence of the blue signal is very shorter when compared to your original modulating signal or your carrier frequency. Okay, so that means in frequency modulation, the modulating signal changes only the frequency of your carrier signal. And yes, obviously, when you take the requirements, that is the bandwidth requirement for frequency modulation, since we are embedding a high frequency signal here, the bandwidth required also, it is approximately 10 times more than your original signal frequency. Okay. Now, how can you generate frequency modulated wave? Yes, here is the device. Voltage controlled oscillator is the device that is used to embed your high frequency signal into your original signal to give the FM modulated wave. Okay, so this is frequency modulation. The total bandwidth required for frequency modulated wave can be determined from the bandwidth of the audio signal. How? So 2 times 1 plus beta into B, where capital B is the bandwidth of the original signal and beta is usually 4. So you can see the number of times it is getting multiplied. So approximately to transmit a frequency modulated signal, we need 10 times more bandwidth than the original signal. And the third parameter is phase. So it is phase modulation. So phase modulation, yes, you can very well see the original signal starts at 0, right? So in the due course of time, the phase of the signal will be altered. That means either a 270-degree shift or a 180-degree shift or a 360. Probably a total round off shift can be applied to your input signal to generate your phase modulated wave. So here what exactly happens is it only changes the phase of the carrier signal, and obviously when we change the frequency, when we change the phase of the carrier signal, it implies that the frequency of the signal also varies. Okay, but actually here the bandwidth required is very much less when compared to a frequency modulated wave, but slightly higher than an amplitude modulated wave. Okay, so see here, this is how a phase modulated wave is generated. So there is a differentiation in phase. This differentiation is given to a voltage controlled oscillator. This oscillator will embed your carrier frequency and it will give the output signal, which is your phase modulated signal. So here is the bandwidth requirement for a phase modulated wave. It is 2 into 1 plus small b the whole times capital B, where capital B is the bandwidth of the original signal and beta is approximately 2. So probably half of the times the bandwidth required for FM is reduced here in PM, but out of the 3, amplitude modulated wave requires minimum bandwidth to get transmitted. Okay, so this is the understanding we will get. So this is just an illustration of whatever we have seen so far. What is modulation? You have an input signal, you have a carrier. So this is your input signal here and you have a carrier signal here. So in the amplitude modulation, you are going to increase the amplitude of your wave. In the case of frequency modulation, see here, you are going to increase the frequency of your wave periodically. In phase modulation, yes, you are going to obviously change the phase of your modulated wave. The frequency remains the same in other 2 cases. Okay, so this picture gives us a very clear understanding of what AM is, what FM is, and what PM is. Okay, so why? What are the advantages of modulation? So yes, we do have certain advantages of modulation as mentioned earlier. There are 2 reasons. First one is to separate the signals and second one is minimize the size of the antenna. So the major advantages, when you minimize the size of the antenna, the cost incurred in building the antenna becomes very less. Okay, so yes, the first one is antenna size gets reduced. No mixing of signal occurs. That means you have a separate path for every signal to travel. Your range of communication increases when you modulate a signal. Multiplexing of signals is possible. Yes, this is a new term for us. Now, what is multiplexing is permitting more than one signal to use the same channel. Okay, the best example is our TV channels. So initially, when I was I don't know whether you have experienced this, but yes, when I was in 3rd standard and all, what will happen is we have had only 3 channels. Probably one is Doordarshan, the other one is some local channel, and that is something given by Tamil Nadu government, which will where the telecast will happen only during the evenings. I hardly remember. And the other one is some news channel that occurs, the DD News. Okay, so what happens is it has a particular timing. That means only early morning 7 o'clock the transmission will start with that sound and all. So probably I think you are not maybe you are aware of the Doordarshan signal. Maybe they will show you in some movies and all. And what happens is they will transmit only during a particular time, and regional channels will transmit only during a particular time. There are no means that both the regional as well as national channels can transmit at the same time. So we did not have that facility. Now, as the technology increased, now we have cable TV. So why this cable TV was possible is because of this keyword, which is called multiplexing, which means now at the same time you can see Sun TV, Vijay TV, DD, News, Podigai, local channels, international channels, all into the same time. Every channel is now broadcasting 24/7. So with a remote you can switch channels. All this is possible only because of multiplexing. What is multiplexing is permitting more than one signal to use the same medium to travel. Okay, so this is multiplexing. And yes, adjustments in the bandwidth is permitted. There are HD channels, there are non-HD channels. HD channels use higher bandwidth, non-HD channels use lower bandwidth. Anything you want you can use using the same medium. Okay, and last but not the least, the reception quality is probably increased into multitudes that you will not even see a single grain in today's transmission medium. Okay, so these are the advantages of modulation. Yes, getting into the last part of our lecture, which is line coding. Okay, very simple. To tell you in simple terms, we have the famous 143 coding. So probably again only in my childhood days, 143 was a shy number for us. Okay, so yes, that is interpreting. Okay, so here what is line coding is process of interpretation only, but what you are going to interpret, it is converting digital data into digital only by applying some means of methodologies. Okay, so yes, there are 3 methodologies here: unipolar, polar and bipolar. Done. So we will see each of these in detail in the coming slides. What is unipolar? The axis. We have x-axis and y-axis in 2 dimension. So x-axis and y-axis, when combined together, we have positive, we have positive, negative, we have negative, negative, and we have negative, positive. Done. So using only a single quadrant for encoding our text or for encoding the digital data is called unipolar coding. Okay. So what happens in unipolar coding schemes is that you can see the data here. The data we want to transmit digitally is 10110. Okay. So you can see very well here the data to be transmitted is 10110. So unipolar line coding scheme here, it uses the positive quadrant and a high voltage defines 1 and a low voltage describes 0. Okay. So you can very well see whenever there is a 1, there is a line here that is in the high voltage part. And whenever there is a 0, it comes to the 0 axis here. And another one, it comes back to that higher value. And another one consecutively does not come back. It stays there in the higher value itself. And another 0, it drips back to 0. So this process continues in your time slots to interpret a 1 and a 0. A high voltage indicates a 1 and a low voltage indicates a 0. So this is unipolar encoding technique, where it uses only the positive quadrant of our axis. Okay. Next one, you have polar schemes. You have two polar schemes. One is NRZ. The expansion here is non-return to 0. Okay. Non-return to 0. Very simple. Say for example, if we are transmitting from 0 to 1, that means 0 to 1 transition does not require that the signal has to return back to the 0th level. Okay, it directly takes for 1 and 0. Done. So what happens exactly here is, for non-return to 0, you can see here the same thing happens, but it is polar. Polar is both positive as well as negative axis. So we incorporate both positive as well as negative y-axis. Okay, I'm not talking about x, I'm talking about y-axis. So see here, we start with a 0. A plus 0 is on the top here. The next is a 1. So it comes back to the negative highest. And the next is a 0. So it goes back to the positive highest and remains there for a 0. And whenever the bit changes from 0 to 1, it comes back to negative high. So 1, 1, 1 here remains in 1 for a negative high and then gets back to 0. This is non-return to 0. So that means the interpretation here is 0 is the positive high voltage and 1 interprets a negative high voltage. Okay. So this is non-return to 0. So again here, this is another example for a non-return to 0. So a positive y-axis stays at 0, right? Now it is a transition from 0 to 1. So it comes back to the negative y-axis. It stays back in the negative y-axis when there is a 0. That means the dark dot indicates that there is a transition and a hollow dot indicates that there is no transition. Okay. So from 0 to 1 and it remains at 0 here. If there is no transition, it means it is a 0. And when there is a transition, it is represented by a blocked dot. So you have a 1 here and another 1, 1, 1. So wherever you get a transition means from 0 to 1. Okay. So it is indicated by a darker dot here. So this is the interpretation of non-return to 0. So the disadvantage of non-return to 0 here is, probably there may be chances or situations wherein we will not be able to interpret the digital data properly. And if we do not interpret the digital data properly, what happens? The interpretation of the signal goes down. If the interpretation of the signal goes, you will not be able to recover the analog signal. And if the original analog signal is not got, the reception will not be proper at the other end. Okay. So this is the disadvantage in the case of polar schemes. And the second one is polar return to 0. So here in polar return to 0, it's very simple. As the name indicates, you can see here, the dotted lines indicates one time slot. Okay. So this shape indicates one signal which represents 0. If you start from the lower part, the negative high, in the halfway you are going back to 0 and you're going for the transition, it means a 0. If you start from high and if you end at 0, it is a 1. So that means the entire time slot is split into half. So this part represents your signal and this part represents your transition, that is from the high amplitude to 0. This is return to 0. Whereas in the previous case, you can see for the entire time slot, it remained in the same amplitude. But here, for the half of the time slot, it remains at the same amplitude. And for the remaining half of the time slot, it goes back to 0. Okay. So this is polar return to 0. And the last coding techniques or line coding technique we are going to see here is Manchester. So here in Manchester and differential Manchester coding techniques, it is actually similar to polar return to 0 and non-return to 0 only. So basic Manchester, what happens here is, see here the sample data is 0, 1, 0, 0, 1, 1. That means if you're starting from a high amplitude, come back to lower amplitude and remain there, it is a 0. From wherever you are, if you're starting from there and to a high amplitude and remain at high amplitude, it is a 1. That means you're not going to change the phase of your signal if two bits are same. So see here, for consecutive two zeros, it starts at positive and ends at negative. Starts at positive and ends at negative. For a 1, it starts at negative and ends at positive. Starts at negative and ends at positive. So this is Manchester line coding. And what is differential Manchester line coding is, it's probably the same as we saw in one of the method of polar non-return to 0. That is where there is a transition and where there is no transition. I told you a hollow block indicates no inversion, no transition, and a block dot indicates there is a transition. That means, see here we start as 0. Okay. So the next one is we are not going to invert. It is a 1. So 1 starts here and ends here. Next is an inversion. From 1 you are inverting to 0. Okay, and here again to 0. And from 0 to you're going back to 1. So here this hollow block indicates a 1 signal from here. And again here you're going to indicate a 1 signal. So this is a 1 in your x and y axis timeline. So this is Manchester line coding. And the second one is differential Manchester line coding, where inversion and non-inversion are mentioned. Okay. So in practical, depending upon the application, any of the coding techniques are being employed to encode the digital data and transmit it over the network. So encoding does not stop here. We still have many other techniques to do encoding and better encoding to compress our data and transmit it over the channel. So yes, that is the end of our class. To conclude with summary, in today's class, we have seen about what is modulation, what is the need for modulation, what is the need for modulation to reduce the size of the antenna and to separate each signal. Okay. So, and we have seen about the types of modulation, amplitude, frequency and phase. And finally, line codes, unipolar, polar and Manchester coding. So that's it for today's class. Any doubts, you can post it in our wiki page using the discussion forum. I or we will be rather happy to answer to any of your doubts. Thank you for joining. Have a nice day. Thank you.